Today we will be dealing problems based on uniform distribution. So our first problem. An unbiased die is thrown. Let X denote the number shown in the die. Find the mean and the variance of X. So this is the question, and we are asked to find the mean and variance of the random variable X. Now, uh, what kind of a random variable is X? Is it discrete or continuous? Yes, it is discrete. So that is, the question is given in such a way that the informations are not directly given as it is. So you have to infer certain things from the question. So the first thing is what kind of random variable X is. You have to ask yourself. So X is a discrete random variable. Now, an unbiased die is thrown. Yeah, that is what they have given you the information, and they have also given that X denotes the number that is shown on the die. So when an unbiased die is thrown, what are the possible outcomes that you can get? Please note it down. Yes, S is equal to 1 2 3 4 5 6. Yeah, and X denote the number of the number shown on the die. So yes, possible outcomes are 1 2 3 4 5 6. What are the values that X can take? X is equal to, yes, X can take 1, X can take 2, yeah, and so on. So these is the primary information that we get from the question. Now again, uh, when a question like this appears where the distribution is not mentioned, by looking at the example or by looking at the case study, you should know which distribution it would follow. Now in a piece of paper you have an information about the X, the values that X can take, and you also know the case, right? So this example has been discussed in the previous video, but I was not referring to this to find the mean or variance. But again, this example has been discussed, and we just connected this example with a distribution. Do you remember that distribution? Okay, yes, it is uniform distribution. Right. So from this question, we get an idea that uh, X follows a uniform distribution. From now on, you will say that, okay, random variable X follows, you can use that terminology, follows such and such distribution. So in this case, X follows a uniform distribution. Now, why does this X follows a uniform distribution? Let's take a look. So before that, we were asked to find out mean, right? So whenever you are asked to find out something, it could be covariance or standard deviation or whatever it is, you just write out the general formula. So that is what I have written over here, the general formula. And then you have to note what all values on the right hand side. Is all this right hand side available in the question? Is the information available? And if it is available, you can substitute it directly. Now the information is not directly given, so here I should know what the values X takes. So as I said before, X takes the values 1 2 3 4 5 and 6. Again, as I said before, it is clear from the question that it is X. Okay, X follows a uniform distribution. Here you will have to make some correction. This is not f of X. X follows a uniform distribution, and your f of X, therefore, since X follows a uniform distribution, what is your f of X, or what is your PMF? So in the equation of expectation, the second thing that you don't know is f of X. So you should have an idea what f of X is with regard to this question. So therefore f of X is 1 by n. Yes. Now let's see what we get when we substitute. So expectation of x is equal to, so 1 by n is a generalized formula. Now in this case, expectation of x is equal to 1, that is your x, multiplied by, here the f of x is 1 by n is what? Yes, 1 by 6. Actually this is plus sign, this is not equal to, plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6. Finally you will get an answer around 21 divided by 6. Okay, so that is the expectation of x. Now similarly you were asked to find out the variance also. So I just wrote the equation for variance, a formula for variance. Again I have this expectation of x with me. Now I have to find out expectation of x square. So let's find out the expectation of x square. I hope all you know how to do this, so I'm not elaborating it. So the final answer of expectation of x square is 91 divided by 6, and the final answer of variance of x is 91 divided by 6 minus expectation of x is 21 divided by 6. The whole square is equal to 441 divided by 36, which gives you an answer around 35 divided by 12. So that was the first problem. I hope you all understood it. Now we'll move on to the second problem. Now in the second problem they have asked you to find out the MGF of x when x, if x follows a uniform distribution and takes the values 1, 2, 3 and 4, and you are also asked to find out mu2. Okay, now let's break down this question. Now here it is clearly given that x follows a uniform distribution, so you have an awareness about what your f of x will look like, and here x takes the values 1, 2, 3 and 4. Okay, now and you are asked to find out MGF and mu2. Now what is mu2? The second central moment. I hope you all remember the previous module. So now in this case MPF is PMF is given, and it is f of x is equal to 1 by n, which is equal to what? 1 by 4, where x takes the values 1, 2, 3 and 4. Now you are asked to find out MTX, right? So you know the general formula of MTX. What is the general formula of MTX? Is given as expectation of e raised to tx, which is equal to summation e raised to tx 1 by n. That is equal to, now you substitute the values. Instead of n over here, it is 4. So 1 by 4, yes. You have, yeah, since x takes the values 1, 2, 3 and 4, you can write this as expectation of t plus expectation of 2t plus expectation of 3t plus expectation of 4t. Okay, so that is the MGF. So your first part is over. Now you have to find out mu2. So I hope all of you know again the formula for mu2 is mu2 dash minus mu1 dash the whole square. Now mu1 dash is nothing but the first row moment, that is the mean of the random variable. So all these small points you have to take in, you have to remember while doing all these problems. Now what is mu1 dash? As I said, it is the mean of the random variable x, or it is the rth row moment of the random variable x. Again, how can you find out mu1 dash? You can differentiate the MGF and give the value t is equal to 0 in the given in the result that you have obtained. So let's see, when I differentiate MTX at t is equal to 0, what will I get? So when I differentiate MTX, I get 1 by 4 into e raised to t plus 2 e raised to t, 2 e raised to 2t plus 3 e raised to 3t plus 4 e raised to 4t. This is a basic differentiation, or the simple differentiation that I have did, which you all have studied in your high school section. And then what I'm going to do is I'm going to put the value t is equal to 0 in this equation. So let's have a look at what we get right now. Yes, the final answer is 5 by 2. That is Okay, here we have got the value of mu1 dash as 5 by 2. Now you have to calculate mu2. For calculating mu2, you have to know what the value of mu2 dash is. And since mu1 dash, we get mu1 dash by differentiating the MGF for one time, and mu2 dash is obtained by differentiating the MGF for two times and giving the value t is equal to 0. Since we have already differentiated the MGF one time and the function and the equation is given by this, you can differentiate this equation once again, and you can give the value t is equal to 0 in the equation. So mu2 dash is equal to, I'm going to differentiate the equation that I have mentioned earlier, and then I'm going to put the value t is equal to 0. Now let's have a look when what I get when I differentiate. What I get when I differentiate is 1 by 4 into e raised to t plus 4 e raised to 2t plus 9 e raised to 3t plus 16 e raised to 4t. Now when I give the value t is equal to 0, I will get 30 divided by 4. So this is just mu2 dash. I have to find out mu2. Now in mu2, I'm only going to substitute the values that I have got for mu2 dash and mu1 dash, and after substituting, I will get mu2 as 5 by 4. I hope you have all understood the problems. Thank you.